To understand entanglement, we are going to need a new quantum theory on light and time. In this diagram, light expands out from its center in a light sphere. The polarization of the photon is set at the creation of each quantized wavefront. This will remain the same however great the distance between them becomes, because when their wave-particle function collapses, it will represent the same moment in time for the entire wavefront. But what is a moment in time? Sir Isaac Newton thought time existed as a thing in itself, and that time is connected to motion. But if time exists in itself, there must also be a process creating new moments in time. In quantum atom theory, time is being created continuously by the wave-particle duality of light combined with photon-electron couplings. When a wave function of light comes in contact with an electron on the surface of an atom, the particle wave function collapses into a new photon particle and also into a new moment in time. There is then a quantum leap of energy, and two-dimensional space on the surface of that atom expands into three-dimensional spacetime as a new expanding particle wave function of future possibilities. When this wave function comes in contact with the electrons of another object, the process will repeat itself again, creating the continuous forward momentum of time. This is very difficult to visualize, but in this oil painting of a geisha girl walking through sunlight, the wave-particle duality of the light will collapse as she walks through the rays of light. She will collapse the wave function into moments of time and space, creating her own space-time. Because of this, the individual observer is the only true reference frame, because they are creating their own time and space relative to their position and momentum. This can explain why light is so beautiful when it strikes an object. It is because we are looking at a moment of pure creation of time and space. In these diagrams, the atom is creating its own time and space in a chain reaction of photon-electron couplings that is called stimulated emissions. Therefore, if the observer looks up, he can see back in time through light years of space. But if he looks down into the quantum world of the atom, he can only see probability. The probability of the uncertainty principle is the same probability that the observer will have with any future event. Because it is impossible to achieve absolute zero, everything is radiating photon energy continuously. From each photon-electron coupling, electromagnetic radiation will radiate out in light spheres of quantized wavefronts. Each wavefront will be quantized at the level of the Planck constant. Because it only takes three variables to explain a light sphere, we have no need of extra dimensions or parallel universes in quantum atom theory. Therefore, the observer will see a dynamically evolving universe in three dimensions, expanding out in all directions. Just like in Einstein's theory special relativity, there is no absolute or universal time, because atoms create their own time relative to their position and momentum. We therefore live in a universe of multiple spacetimes, and each spacetime is governed by the Lorentz contraction of time. Because this is a continuous process at the same speed that light moves, the expanding wave function of light between the atoms will always be a universal constant, independent of the motion of the source. The wave function represents the time continuum at the most fundamental level. Time only moves forward because the probability of the wave function only works one way. We always know the position or momentum of a quantum particle in the past. Every object in our universe creates its own time and space by collapsing the light waves of electromagnetic radiation into new quantum particles that will have their own position in space and time that the wave function never had before the collapse. And because the observer can choose when and where to collapse the wave function, we have free will to create our own future. The wave-particle duality of light, or electromagnetic radiation, is continuously creating a blank canvas for the observer that she or he can participate in. This is what Socrates called a sea of beauty. If the observer does not collapse the wave function, the quantum particle will only have the momentum of its own particle-wave function. At a fundamental quantum level, the observer is the observed, within his or her own created spacetime. Therefore, the more accurately we know the position of a quantum particle, the less certain we are of its momentum. And if we know its momentum very accurately, then we can't be quite sure where it is. This is because to observe the quantum particle, we create a photon-electron coupling, collapsing the particle wave function into a moment of time and space that is part of the observer's own created spacetime. The best way to see this happen directly with light is the double slit experiment. The light will expand in all possible directions as a wave-particle function of quantized wave fronts. When the wave function reaches the screen with the two slits, the photon will react with the electrons of the screen. This will collapse the wave-particle duality of the light, creating new moments in time and new quantum particles in space. The part of the wave that does not come in contact with the screen will expand in all possible routes, going through both slits as two light spheres of quantized wave fronts. Constructive and destructive interference between the waves will cause them to superimpose or cancel each other out. When this wave-particle function comes in contact with the screen, it will collapse, creating new moments in time and quantum particles in the shape of an interference pattern. When the observer turns on a detector to determine which slit a photon passes through, the interference pattern collapses. This is because to observe the photon, we have to create a photon-electron coupling, collapsing each wavefront into a new quantum particle that will have its own position in space and time. When we turn the detector off, we remove the photon-electron coupling, and in time, the interference pattern will reform. Just like in Newton's first law of motion, the interference pattern will continue to maintain its state unless acted upon by an external force. The only problem is the external force can only see one moment of infinity. This theory is very simple, but I think it is also very beautiful. It can explain all the paradoxes of quantum mechanics. It also explains why light is a universal constant, and why we have the forward momentum of time. But above all this, we have free will for the creative evolution of our own reality within the dynamically evolving universe of Einstein, and quantum mechanics and classical mechanics of Newton are united